And whenever all the memory locations are used and there is nothing inside the pool, my system will say that it cannot allocate the memory to the new object because there is no object available inside the pool. Hi all, this is Nick Karan. So in the previous lecture, we talked about in what kind of cases we should use memory pool inside our system and how it can help us improving the performance of the entire system. So in this particular lecture, we'll try to understand what is the idea behind implementing memory pool using C++. And this particular idea is not specific to any of the programming languages. Instead of that, you can use very same idea to implement memory pool concept in any of the programming languages. So if you are already aware of theoretical part of the implementation, you can skip this particular lecture and directly jump to the implementation part, which is there in the next lecture. So let's start the discussion. So let's say using memory pool, I have to manage the memory for this particular class. That is, for this particular class, I have to create the objects at runtime very frequently. So I have to manage the memory for this particular class using memory pool. And I am calling this particular memory pool as memory manager. And this is the order class. So the total size of this particular order class is, so for now, I am assuming that integer takes 4 byte. So 4 byte for this particular member variable and 4 byte for this particular variable. And there can be other member variables as well. For the simplification purposes, I am taking just 2 variables. And this is our memory manager class, which will manage the memory for this particular order class. And this particular memory manager contains different kind of member variables. And at the same time, this will also have different kind of functions as well. So we'll try to understand them in the implementation part. Here we are just trying to understand the theoretical understanding how we can implement the memory pool. So let's say in worst case, I have to create 10 objects of this particular order class. And what is the total size of single object? That is 8. So in total, how many objects are there? Number of objects will be 10. And what is the size of each object? The size of each object is 8. So what will happen is, this particular memory manager will take 2 variables as input, which is how many number of objects you want to manage and what is the size of each object. And we'll provide this entire information to memory manager when we'll create the instance of memory manager. So when we'll create the instance of memory manager, at that time we'll provide these 2 fields. So that way memory manager will be aware that we want to manage 10 objects and size of each object is 8. So what memory manager will do inside the constructor is, it will take the number of objects and at the same time size of the object. So memory manager will allocate memory for 10 objects, each having size of 8 byte. So in total, it will allocate this much amount of memory, which is 80 byte. And this particular memory will be allocated using new keyword, that is memory equal to new character, and how many characters? 80. And here I am assuming that one character is equal to 80 byte. So this particular variable, which is memory, will keep track of the memory allocated using this particular new keyword. So how this will look like is, so let's say this is my physical memory and this is from 0 to, let's say, 99 byte. So what will happen is, I have allocated total 80 byte. So from 0 to 79. So this particular memory member variable will keep track of memory from 0 to 79 byte. Now what I will do is, I have to create the 10 objects, each having size of 8. So now what I will do is, inside this particular variable pool, what I will do is, this pool, which is a vector, I will keep track of starting address of each object. For example, let's say the one object size is 8 byte and number of objects are 10. So in total, I'll have to track 10 memory locations. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So inside this particular vector pool, I'll put the starting address of first object, which is 0. And inside the second cell, I'll keep the starting address of second object, which is 8. That is, from 0 to 7, my object 1 will be there inside the vector, and from 8 to 15, my second object will be there inside the memory. So that's how I'm assigning values to this particular vector. So here I'll keep 16, here I'll keep 24, that way here I'll have 72. So till now what I have done is I have allocated the memory using new keyword to the 10 objects of this particular class order, and each object is having 8 byte, and inside this particular pool I have kept the starting address of each object. So now let's say at runtime I have to create one object of this particular order class. So what I will do is order O equal to new and order. So this particular new is not the same new which we have used to create the memory. Instead of that, we'll provide the definition to this particular new keyword. So internally what this new keyword will do is it will fetch the last element from the vector, which is the address, that is 72. So the memory to this particular order object will get assigned from 72 to 80, and I am calling this as O1 because I have used this particular memory location. So I'll remove this particular memory from this particular vector. So this particular element is no more there. So in total there will be 9 elements as of now inside the vector. So let's say now I have to create another object of this order class O2. So what I will do is I'll check whether something is there inside the pool or not. So 9 memory locations are still there inside this pool. So I'll fetch the last one. So I'll allocate the memory from 64 to 71. And I'll delete this particular element from here because this is already used. Now let's say my system has to free this particular object. So what my system will do is delete O1. And what this particular delete will do is it will keep this particular memory location back to the vector. That is, it will put the memory at this particular location, that is 72. So now wherever my system needs to create another object, it can use this particular memory location. Now let's say after some time my system has to create another object, that is O3. Then I'll pick the last element, which is 72 from the vector, and will use that particular memory location to create the memory to this particular object. Now if my system has to delete this particular memory assigned to this particular object O2, again this will do same thing, delete O2. So this delete will keep this particular memory back to the pool, which is 64. And this memory location is already assigned to this particular O3. So this is no more there. And whenever all the memory locations are used and there is nothing inside the pool, my system will say that it cannot allocate the memory to the new object because there is no object available inside the pool. So this is the overall idea behind implementing the memory pool. So if I summarize the entire lecture, then I can say if I have to manage the memory for some class, I need to figure out how many objects at runtime I want to manage, and I'll try to calculate the total size of those objects. So in my case, I have to manage 10 objects. So total size of those objects is 80 byte, and I am representing all these 80 bytes with character. So I'll assign memory to this particular member variable using new keyword, which is equal to the total memory required for all the objects. And I'll keep the starting address of each object inside the vector. Whenever I need to access the memory from the pool, I will fetch the last element from the pool. And if I need to delete that particular object, I'll put back the memory to this particular pool. So this is how I'll be managing the memory for 10 objects of this particular order class. I hope this particular lecture was helpful for you. So let's meet in the next lecture where we will implement this very same idea using C++, and at the same time we'll also try to compare the performance of this particular idea using our normal approaches. Thank you.